Good afternoon, everyone. My name is Suematsu from Fujikura, Tokyo, Japan. I'm grateful to everyone for giving us this opportunity. Today, I will explain according to this title. This title was requested from the organizer of this workshop. So I have come here, Penang, from Japan at this time. I will explain it by two people. In the first half, I will explain the status of broadband and FTTH in Japan. And then Mr. Lee explain about the FTTH solution in the second half. Let's get started from first session. Status of broadband service in Japan. This chart shows the transition of telecommunication service subscribers in Japan. Fixed line is maintained approximately constant. Oh, sorry. Yeah. On the other hand, mobile services greatly increased. NTT ports service is decreasing rapidly from 2005. The number of NTT post subscribers is declining annually about approximately 10% as a result of the shift to mobile phone and IP phone. Broadband of FTTH subscribers are growing steadily. So NTT plan to migrate from PSTN to IP network completely until 2025. PSTN switched both will reach the end of their useful lives around 2025. NTT have to migrate until this time. It is expected to take around 5 years to migrate from PSTN to IP network, and the migration will begin around 2020. A smooth implementation of PSTN migration requires adequate notification to users. Now, it is a publicity situation in Japan. NTT announced this plan in 2010. The migration has much work to do and need a lot of time. I get back to talking about FTTH. Total broadband user reached around 40 million, and FTTH user reached 20 to 3 million. DSL is switching to FTTH for certainly. And FTTH are growing steadily up to this time. DSL users become less than third part of FTTH. The remarkable point, others are increasing rapidly since last year. Others are broadband wireless access, like WiMAX and LTE. The net increasing of FTTH subscriber is decreasing little by little. And the net decrease of DSL subscriber is maintained still constant. The difference between the number of the net increase of FTTH and the number of net decrease of DSL is very few. It means the newcomer of FTTH service are very few. Expect the migrator from DSL. The net increase of NTT's FTTH subscriber in first quarter financial year 2012 was down by half compared with the same period last year. It is not the decrease of the new subscriber. It is the increase of the cancellation especially. Why? First reason. The competitor of NTT has released its new pricing service, which offers a big discount if the user subscribes to both fixed line and smartphone. NTT's customer move to this service to save the smartphone charge when they buy a new smartphone. Meanwhile, in case of NTT, the service of fixed line and the mobile service are carried on the different company in NTT group. So, NTT is bound to sell the package sell both service by the telecommunication business law in Japan. Second reason, the main terminal equipment of broadband are changed from personal computer to smartphone or tablet. It means it is important to be able to connect at any time, anywhere. These use don't always have to need a fixed line. Therefore, WiMAX LTE plus tethering are threat of FTT services in the days ahead. FTT business consists of 3 key points. That's opportunity, revenue, and profitability. Opportunity means expand the area coverage. Revenue, create a new service. Profitability, reduce the CapEx and OpEx. The currently main service in Japan are high-speed internet access, low-cost, high-quality IP telephone, and TV on-demand video. Most of the FTT users in Japan use these 3 main services. After this, it is necessary and very important for the future to develop the new application, utilize the ultra-high-speed new FTT service. Otherwise, the broadband wireless access may take the place of FTTH. Now, Japanese telecom carriers are considering to create a new business of FTTH in every field through collaboration with a lot of companies. Last month, NTT West President spoke some new business in the lecture presentation. For example, service for remote musical concert, service for living room study, energy saving support service for house use, medical image storage service, remote control system for cattle grazing, life support service for the elderly, and all that. NTT West has conducted trials using ICT and FTTH network to meet regional changes, revitalize local communications, and improve service for citizens to realize a smart town. I think the cooperation between local government and the telecom carrier is very important for deployment of FTTH. I hope this Penang will be the best and the brightest smart town in Malaysia. The area in which some kind of the broadband service provided have already reached 100% at 2011. The high-speed broadband service reached 97.3%, 52.4 million households in March 2012. The difference of the coverage between broadband and high-speed broadband shows the need to deploy into the rural area. Telecom carriers are expanding the FTTH into rural area, providing FTTH service through to solve the digital divide. FTTH service in rural area is unprofitable. Therefore, the government assistance is necessary for carrier. NTT East and NTT West have cooperated on construction of IRU project and provide broadband service for IRU network for approximately 19 local governments through the end of March 2010. And NTT provide FTTH to more than 650,000 households under IRU contract. This chart shows the structure of IRU. At first, local governments call for bid on the facility, operation, and maintenance for the FTTH service. And then, local government leases the facility for FTTH to the contractor of IRU. The contractor, who is usually telecom carrier, provide FTTH service to the citizen in the local government area and gets revenue from the citizen. In case of rural area, the distance from central office to user's home is longer than urban area. Therefore, it is necessary for the rural area network to expand the distance over which optical access between OLT and ONU can be provided. The EPON transmission distance reached 50 kilometers in Japan. This chart shows the transmission of kinds of FTTH subscribers. About 6% of all are single dwelling unit subscribers, and the single dwelling unit ratio is increased slightly. This penetration ratio of FTTH between single dwelling unit and multi-dwelling unit is about the same as the housing ratio between SDU and MDU in Japan. This chart shows the transition of FTTH subscribers share rate. NTT nationwide share of FTTH is kept above 70%. But there is a big difference between NTT East and NTT West. The share of NTT East is 41.9%. On the other hand, NTT West is 32.3%. This difference is around 10%. This chart shows, This chart shows the FTTH subscriber share rate, prefecture by prefecture in Japan, as you see from this slide. There is a big difference between East area and West area in Japan. NTT East is a near monopoly situation in the business area. But on the other hand, NTT West compete with the power-affiliated companies of each region in the business area. So the FTTH subscriber share differs according to the area in case of Japan. Thank you.
Good morning, good afternoon, everyone. Okay, thank you, Sema-san, for presenting the broadband status in Japan. Okay, let me introduce myself first. My name is C.S. Lee, representing Fujikura Ferro Cables. We are located in Penang. And we'll continue the presentation on the solutions and the products used in the FTTH networks. So for the FTTH solutions, what we will see on the how we're going to wire, because we see so many how the status on the Japan, how Japanese they do the wiring in the SDU or MDU solutions. Okay, first we'll look at the FTTH end-to-end solutions. Okay, this is just a broad view of the FTTH solutions, but we'll go into details on the SDU and the MDU. As what we see, the main distribution for the FTTH network will be the SDU or the MDU. Okay, so we'll look at the SDU. Okay, so for SDU, this is what a lot of telco they are doing. They are having two stages of the FTTH network constructions. The first one will be the plan constructions or plan stage, and the second one will be the service or the construction stage. Okay, so for the first one, the plan stage. Okay, the plan stage will be from the central office or from the OLT unit up to the area section, what we call the area cables here. Okay, area cable is very widely deployed in Japan because in Japan they're already having the pole, which is a ready infrastructure. So there's no need to do all the trenching, all this works. Okay, so over here, the plant construction, this is based on the telco, their forecast. And later on, this is an important stage because what the telco, they can generate money is from the service order. So we'll talk into more details on the next few slides. Okay, so over here, we'll touch on the free access solution as well, which is very widely deployed in Japan. Okay, so maybe lots of you not aware of this free access solution, so we'll discuss about it in the next few slides. Okay, so we'll look at the area section first. Okay, so for the area section, as you can see the figures right here, okay, the cable will be planning on the pole here, so it will be hanging on the pole. So when the customer coming in, the telco will set the closure at the drop points here and connected to each customer. So let's say the customer is coming here, then they will set a drop point here. Okay, so why Japanese they're using the free access solution as compared to some of the telco that deploy the network, they use the so-called fixed access solution. They set out a boundary for, let's say, from people from region A to region B. It's covered by the distribution point 1. And for another subscriber, they're covered by another distribution point. Okay, so we'll see about the free access and fixed access solution. What's the differences of it? Okay, so for the figure on top, the free access solutions. Okay, so when this is an existing subscriber, there will be a drop point near to the existing subscribers. So if let's say there's another new subscriber coming in on a miles away, then this drop point may be not suitable to be dropping here due to the distance. So another new drop point can be located at the nearest points, maybe here. So another subscriber coming in, we can set a drop point here. So the solution for this actually is very economical friendly as compared to other fixed access solutions. As we can see here, the drop point need to be set at the fixed positions. So if let's say in the planning stage, that we think at this point there will be customer coming in, so we need to have a cable bundle instead of a drop points. So this is some illustration like how the free access solution can be catered for the future demands. Okay, next slide we'll see on the cost comparisons of the fixed access solutions and the free access solutions. Okay, so if we can see the line on the top, the red line here, actually this one is the fixed wiring. Okay, so for fixed wiring, which is more expensive, and for the free wiring actually it's much cheaper even though for a 10-year time frame. And this we are looking at the 100% take-up rate. Okay, so 100% take-up rate is an ideal case. I think we don't have the 100% take-up rate for this kind of ideal case. So if let's say the take-up rate would be like 30% or 50% or even 70%, so the differences between the free wiring and fixed wiring, the differences will be much bigger. Okay, so this slide shows the residential section wiring. So when the order coming in, okay, the cable, the drop point here will be connected to a point we call demarcation point. Okay, so for the demarcation point, the cable will be coming in. The reason that we set a demarcation point outside the customers outside of the wall is because we want to do all the testings before we going to contact to the customer that we want to go into their houses to do all the installation works. So this will save the time that we need to contact with the customers, save their trouble as well. Okay, so next we will look at the MDU wiring as what we heard Dr. Bernard and a lot of speakers talk about the MDU solution, MDU wiring. So MDU wiring actually is a very difficult part in most of the application deployment sites. And what the Japan entity they are doing, actually we can divide it into two major common methods. Okay, the first one we call it centralized splitting. Okay, so for the FDH or ODF, ODC, whatever it called, which will be installed inside the subscriber distribution room. Okay, so inside here, they will be having the splitter here. Okay, so whether the splitter is 1/8, 1/32, or any ratio of it. So the splitter will be installed here, and the outside cable actually coming from the outside plant, connected to here, and go through the splitter and split to each user. Okay, so the reason that we introduce this kind of methods It's because that this method is they can install inside the existing ducting. So let's say the existing ducting, they already got the copper cables inside the ductings. So the low friction cables can also be installed inside. We'll talk about more about these products in a later stage. Okay, the second one we call the cascaded splittings. Okay, cascaded splitting, the concept would be quite identical to the previous one, but the differences is that on each riser floor, we're having a splitter module. So they were splitted on the first stage here and second stage at each riser floor to each customer, and the connection will be the same using the low friction cable or indoor cables. Okay, so we talked about so many about the solutions already. So we will look at the products for the deployments as well. Okay, so the SSW cable is what we mentioned earlier for the SDU solutions, actually which is a square shot of the construction here, and this is a messenger wire to support the cable width. Okay, so when the cable coming in, the drop point can be set out at any point due to there's a separator here, the cable slack here. So, which will be easy for the cable installations and for the drop point installation as well. Okay, next, very key components in the FTH solution, especially for the MDU, which is the low friction cables. Okay, low friction cable, if we compare conventional type of cable, okay, the friction is much lower, about 80%. The size also much lower, 1.6 times 2.0, compared to conventional one, which is about 2.3 times 2.0. Okay, so we will look at some of the demonstration on these low friction cables.
Indoor optical cable introduced here is a landmark technology. The fine and low friction indoor optical cable introduced here is a landmark technology that dramatically reduces costs. Indoor optical fiber cables. To make for more efficient use of existing pipes, NTT Laboratories has developed a cable having slim features and superb wire drawing properties. First, it was concluded that a square structure 1.6 millimeters by 2 millimeters in size proved optimal. Second, a new low friction outer sheath material was developed by adding silicon. The installation of this wiring demonstration is much more severe than that of an actual multi-dwelling unit. Here, a fourth optical cable is pulled through an existing pipe. And here, a woman pulls the 20th optical cable. This demonstrates that conventional products cannot be pulled through, and that our newly developed product easily can. The cable providing method is also improved compared to the conventional one. What's more, our new product has better bending rigidity. This enables a single worker to install cable using the push-in method without entanglement with any existing cables. Wire drawing properties are also better, even in the case of a damaged pipe. The worker experiences almost no friction resistance, even with more than 20 existing cables.
Okay, next we'll look at the ultra-flexible cables. This will be installed inside the houses. So this will be what we call the layman cables, because the normal cables we need to aware of the bending radius, everything. But for this cable, even that you can treat it like a normal LAN cables. So everyone can be handled. So we'll look at some of the comparisons of this ultra flexible cable compared with the normal patch cords. Okay, so on the left-hand side, we can see this is a normal ITU-T G652D, okay, R7.5 compatible patch cord. So when we bend the cables, so we can see the losses actually is quite significant. Okay, so this is before and after the bendings, so which is very significant. Okay, and then later on, we will look at the ultra flexible cables over on the right hand side here. So the loss is here, and even after how you twist it, so the loss is still be the same. So there will be no interference of your optical signals. So there will be no any problems. So return back, still the same. No any kink, no any problems on the cables. Okay, next we'll look at the splitter module as what we talked about. Okay, so as the size, the footprint of this, the splitter module actually is very small. So this splitter module actually can be installed inside the existing cabinet. So let's say we having brownfield installations that we don't have much spaces. So this one actually can be come into the play. We put inside the riser, then whether there's any spaces, because the footprint is very small, only about 38 mm, the width of it. So which can be installed in any places. So in the cases that if the riser is not being covered, so we can put inside boxes. You can have 1 or 2 or 3 type of the splitters. So the interfacing of it actually we're using the connector for easy maintenance issue. So what we not recommended is we recommended for the last mile usage, we recommend to use the connector rise for the easy maintenance. Okay, so now we'll talk about the field installable connectors. Okay, see this is the first field installable connector I will talk about today. I will talk about 2. Okay, this is the mechanical type of the field installable connectors. Okay, we can see the mechanism right here. Actually, there's a pre-installed fibers right here. So during the installations, there will be no polishing required. Okay, so the installation is very simple and no excess length will be needed. So because as what we mentioned by our previous speaker, they're talking about the labor cost is very expensive. And this one, because there's using the low friction cable, the grip type, so we are not going to handle on the excess fiber length. So this one we save on the labor cost. Okay, so which is also fully compatible with the standard SC connectors. And as we can see here, the insertion loss 0.5 dB, but our typical loss will be about 0.1 dB. And we have different range of the products with the SPC, APC, or APC angle cliff. Okay, so this is the procedures of how we assemble fast SC connectors. Okay, so the installation time for this will be about 2 to 3 minutes for trained workers for after a workshop. So this is all the tools that we need here. Okay, so this is a stripper to strip away the fibers, the fiber cord things. Okay, so after stripping, we need to clean it to make sure that it's clean. And later we need to do the screenings to make sure that the fiber is not break. Okay, then we are using the fiber cleaver to cut the fiber to a perfect angles. Okay, then this is to verify the dimension again. And we need to conform the guide. Then after setting, we need to confirm the length again. Okay, so we will just slide through the guide rails. And we need to check the cable bending to make sure that it's properly engaged with the pre-installed fibers. Okay, this is too much bendings and no bending, which is okay, so it's very simple, and I think installation is less than 2 minutes. Okay, the next, the few installable connector we'll talk about is the fusion type of the connectors. Okay, so what is the significance of the fusion type connector as compared to the previous one, the mechanical splice type? Okay, this one will require the fusion splicer. That means we need the electrical power to do the splicings. And the advantages of this is we can see on the return loss side. Okay, so for just now the slide we show that for the APC angle, the maximum we can reach is about 60 dB for the return loss. So if let's say we want to use for the network that they are using the analog videos, so this one will come into play because we need a much higher, much lower the dB loss for the return loss. Okay, so this is some kind of the assembly process, but what we need is we need an additional equipment, the fusion splicer, to do the assembly process. Okay, so we talk about the network construction, everything. So we need to touch on the network maintenance as well, because even if without maintenance, no matter how good your network is, you should be useless. So according to a study from in the IC meeting in EMI at the Quebec City on 2006, okay, this is the conclusion they met. Okay, so after matting and dematting of the connector for 5 times, the dB loss is about 0.5 to 1.1 dB. Okay, we can see the figure here. This is first matting, third matting, and the 5th mattings. So if let's say we got 10 connectors in our networks, and every connector is dirty, and the dB loss is let's say 1 dB, we are having 10 dB loss increase. So which is very significant to the network losses. So what we need to do is need to do a cleaning, and what a lot of the contractor or they are doing is they're using a very conventional way to do it. They're using cotton bud with the alcohol to clean it, but the way if they do it that way using the cotton bud, it's like we having different type of the contractor. They're having different kind of skills. So maybe contractor A, they can clean really properly. Contractor B, they'll just anyhow clean it, and connector C will also just anyhow clean it. So the network having some inconsistency in the dB loss. So what we introduce here is a one-click cleaners, which will make every cleaning of the contractor will be consistent. So for connector A until connector Z, without any training, so they can just do it. So for this, we can do on the female end of the connector and the male end of the connector as well. Okay, last but not least, I'll touch on the systems of the fiber monitoring systems. Okay, what we call it FIMO. Okay, so the FIMO systems will be connected to the server on the RTU side. RTU is the remove test units. Inside there's an OTDR unit and the optical fiber selectors, which will be connected to the outside plant cables, and it will be connected with the fouling sensors and all those fiber, the dark fiber monitoring or active fiber monitoring. So when the fiber is being cut or there's any trouble on the site, so the system will prompt the maintenance staff and the site staff to go to the site promptly to let them rectify the problem and solve the issues. So once the staff going to the site and solve the issue, the alarm will be dismissed. So this can save on the cost of the deployment, because if let's say we need to check the OTDR on every Unix, which will cost a lot, and this one is automatically they will generate 24/7, 7 days a week, so which can save on the maintenance cost as well. Okay, so last but not least, I'll showcase some of our products here. This is our products. We include everything, include the closures, the cabinets, cables, fibers, and the tools as well. And this we take from the Asia Pacific Council, the FTTH councils. Okay, this shows the leading economics with the FTTH penetration rate, and Fujikura has supplied quite significantly to all these countries, include Malaysia, Indonesia, US. And this is currently our field of one of big projects in NTT, in Malaysia, in Singapore, in US as well. Okay, so thank you so much for your patience for the last 30 minutes. So thank you very much for your attention. Thank you.